Dann, wie gestern angekündigt, Deutsch oder Englisch? Mir ist es egal. English? Okay, then English. Then, okay. Good morning. Hope it was not too late yesterday after the duck. And you can still remember me, that I was the chair yesterday. So, yeah. So, power is nothing without control. First, a few more words about me. So, Marco Achtziger, I'm principal key expert at the Siemens Healthineers. Yeah, they're also working as test architect and also working in the project as a lead software architect for one of our biggest software projects. And because I still have some time left, because I work part-time and have 2 small kids, I am also trainer for our test architects internally to make sure that the next generation of test architects is on the same level as the ones before. And coming to my project, so I will not go into detail here, of course, Siemens Healthineers. I'm working in a project with 30 Scrum teams, millions lines of code, aged roughly 2 decades now. Damn, I'm old. And of course, globally distributed, India, Hungary, fortunately not US, not because of political reasons, but when you try to work with US colleagues and Indian colleagues at the same time, you're the lucky guy in Germany. So it's really hard to set up meetings then. And yeah, but the organization, of course, also has offices in the US. Depending on the project, we also work there. So globally distributed, huge, and yeah, normal project in our case. First of all, mutual expectation, for whom the talk is not interesting for. When you live in that land, you ask yourself, continuous, what? What he's talking about? So continuous integration, continuous delivery, you're not interested in, but I guess that's not the point here on that conference. All your tests are stable. Yesterday we had a few presentations about flaky tests. I think they are a thing and you cannot ignore them. Your impact is always known, so every change your developer does, they exactly know what will happen in the complete system. Then this is also not for you. And one of the best things which can happen to you, of course, for every single change which is committed to your repo, you can run all the tests in the repo which are available. If you can do that, totally uninteresting talk, grab a coffee. I can give you any more insights there. When I thought about what title for that thing, that marketing campaign came into my mind. And it gives a little bit of the impression where I'm heading at is, by the way, who still knows who that is? Who's old enough that Usain Bolt was not always the fastest person in the world? That's Carl Lewis. And he was the guy for Usain Bolt being the fastest sprinter. And he had this advertising for Pirelli tires. And when you realize one thing, I think I have a laser, that detail here. Of course, it was our tire manufacturer. But the point here is, and that fits to the presentation, I mean, that's the fastest man in the world. But if you put high heels on him for the race, he will not be able to win the race because of reasons. I mean, run in high heels, I never did it, to be honest. But I guess, at least my gut feeling tells me, doing a 100-meter sprint in high heels is not the best idea, typically. And that's the point. We were in a situation where we had a lot of machines, and yes, my prompting skills are very bad, I have to work on them. We had a lot of machines, we had a lot of tests, we had a lot of load on the system, but for example, we were in a situation where simply putting more power in the system by putting more bare metal machines into it slowed us down. We really had situations increasing the number of machines to execute tests, suddenly the time took longer. What was the problem? Network, because suddenly we had to distribute to more machines, and then the distribution step of our binaries took longer than the overall thing. So we got slower. At the end, that means if you don't address the underlying root cause, then you can not scale anymore. So it was not, that was the point in that time. And then fortunately, there's this saying, or what you can often do is architecture to the rescue. So I really like that quote because it makes people think sometimes. If you think good architecture is expensive, try bad architecture. And yeah, that's the point. So you will have some kind of architecture in the system. Either you worked on it and have some structured architecture, or it simply happens. And if it simply happens, typically we'll also have scaling problems and everything. But the point is, if you want to solve some systematic problems, you also have to apply architectural patterns, in that case, to your test execution system. And that's what we did. And of course, as I did that with an animation. And of course, that's because simple things are typically the best things. So KISS principle, the architectural pattern we applied is quite simple. So when you start with the changes, you determine the impact. Then you have some kind of a format in between, exchange format. Then for that, you resolve the tests for the impact. Again, you have some JSON, binary, whatever format, so interface between, clearly defined. You post-process what should be done there. Again, you have some kind of a format in between, clearly defined. Then you have the execution, and then you're done. At the end of the day, that's a typical or very, very well-known pipes and filters architectural pattern. Nothing special, nothing fancy. Main point here is, what we did is we divided our test execution process really in these 4 steps and clearly defined interfaces between them. So at the end, and we did that also recently, we can exchange parts there, we can optimize parts in there without having effects on the other parts. And that makes it quite easy to scale now, or in the past, to scale out again with our test execution. Getting a little bit more in the details of the different steps to give you an impression what we did then inside of these steps is, first of all, determine the impact. And when it comes to code changes, of course, you have typically two different extrema. So you can have this one little impact, code change, which really does nothing. You do not care at all in the system. So this cute little puppy sitting in his cushion. So yeah, nice to have a look at, but not so serious. So I would not be afraid of that puppy. Other thing is, we all know that legacy code, 10, 20 years old, no one touched there, no one knows what happens. You change one line of code, and this happens. Whole system is down, nobody knows why, because I changed something there, now something fails there. Of course, that's then a totally different thing. And for such a code change, you have to decide, okay, should I execute more things? And what we decided on, or what you can do there, so when you determine the impact, so do I execute tests only for the really stuff which is currently changed, for the change targets, for example, or DLLs when you're in web, your subfolder or whatever, or you can use tools to get the dependency information about your system and say, okay, maybe that target and all the targets which are depending on that, if you have there some layered thingy. Or what we see more and more is, of course, and we also tried that out using AI on that. So we still have a look on that. But currently, we still have a static dependency analysis there. And our most common solution there is, the current changed area plus everyone who's depending on it. That's now our interesting part of the impact. And that's how we resolve, okay, where should we look for tests to execute after developer committed its code. And the output there is really pure JSON. I think now we moved to JSON. Previously it was an XML, but it's a list of files simply saying, okay, these are the stuff, the areas in the code base where you should have a look for tests to execute, which could be potentially impacted. And that's it. Next thing is then, now we know where we should look for tests, but what tests to execute, and that gets more and more interesting or important as your project gets older or evolves, or how you want to call that. And why is that a really challenge at the end is these 3 graphs. So this is the number of builds. That's the number of builds per week over the years. So I just realized yesterday evening that the 2025 has dropped, but that here comes because I generated that graph, I think, in March or April this year. And then, of course, it dropped because data was missing. But here we stabilize at around 5,000 builds per week, only in my project. So that's not Healthineers data, that's that one project I'm working in. And we run roughly 5,000 builds per week. That's the number of test cases in that project. So over time, we realized that tests are maybe a little bit important if you want to do stuff continuously. And it has grown over time. And here, I think we have roughly 300,000 tests in the system, roughly. So we have to decide out of these 300,000 tests, which tests should be executed if something is changed. And here, that graph, that shows, because just having the tests doesn't mean you run them, by the way, but when you have a look at that graph, which correlates if you have a look, growing number of tests and growing number here, one box here means or how to explain, so over time, the test execution means if it would be one box simply laying down here, would mean we would have one test machine utilized for 100% all the time. And as you can see here, that's here roughly 50. I think that was a peak with 80, where we did some misconfiguration. Also, as you can see it here, that peak is also here. But here, roughly 50 means every month we produce versus 50 months of test execution time. Means we need at least 80, 90 machines to be in a normal state that we can always serve the stuff when the requests come in. Okay, but that you have to then think about, okay, how to do that. And of course, we tried also machine learning in the past, but that was not so successful, to be honest. Of course, we still have a look on new approaches with Gen AI currently, but are not there that we would say we can replace our proven solution. And there it's quite easy. We place in the different parts of the system simply files, XML files still. And they can simply write there, the developers, if that part is changed, please execute these tests. And that's easy to understand. The developers like it because it's directly besides their code. So if something changes there, they can also influence the test execution. And you can also do that on different levels and have there a more fine-grained thing, but that makes it more complex also. But really easy, have there a file. There's a example. No, that's the output of that run. So really a file simply saying, if that area of my code gets changed, please run these tests. And then you get a list of test cases or test assemblies to execute in the system to make sure that the impact is well tested. Of course, again, you can use different strategies, run only unit tests, run also tests of other affected targets, whatever, as mentioned. But the thing here is really plain, simple text file, comparable to the ownership files, maybe in Git. And then you get a list of test assemblies to execute. But as you have seen, our execution time exploded also over time. So we also added there a post-processing. So now you know which test assemblies to execute, but we added there also then a feature because the system got under higher load, because also in a test assembly, there can be in one test assembly 10 test cases, in the other test assembly can be thousands of test cases, meaning that could be quite unbalanced. And we also added a feature there that you could add a configuration then for every test assembly. Hey, if you execute me, please split me in several runs, do whatever. Please only run a specific scope of me if something is changed, simply to make it possible to give the developers and test developers the possibility to bring down the partitioning into a more balanced way to make sure that not one test assembly takes 1 hour and all of the others are done in 5 minutes, and then you wait 1 hour for that single thingy. And you can do multiple things there, also define what test environment the test should run in to make sure that the right machines are selected and stuff like that. but again, quite simple. It's in the same format. Also on the test side, there's a file which describes simply all of these things I said to make sure that also again the test developers can change that with every commit they do to make sure the test execution still fits the current implementation. And for what you need there for is, of course, data. You have to know that one test assembly takes longer than the others, for example. And that's where we always emphasize or tell the people, if you want to change something, please try it or do it based on data. I mean, when you have a look at your regression tests, might be a surprise for you, but I'm very sure that when you have a look at your regression test suite, that I would say 70 to 80% of your tests you run there quite often are always green. And that's, for example, where you could decide then based on such a data, okay, why is it running in every commit? We could also do that once a month or once a week. As soon as it fails, of course, bring it back to a more frequent execution. But why execute it with every change if the likelihood that it fails is quite low? But you get that out of such data, and we track the data since years for our tests, so every execution we can do that, and can also then optimize afterwards again our pipelines to double check, okay, should we partition differently, should we run tests in different stages, simply to make sure that we don't run the long-running tests when they are not really needed. And what's also a thing, and that's something I would emphasize also, is one disadvantage is, of course, all of these things up to now, I think, are pretty simple. I mean, get a list of assemblies, get a list of test assemblies to execute, check how they should be splitted. Quite easy. As always, simple features combined together can, at the end, be very complex. And what I would do differently now is that I would definitely give there more visualization for the developers who use the tooling to make sure they see if something changes, what would that mean in the test execution system, what would run. Because at the end, people were quite confused sometimes why some tests have been executed or not have been executed because of their changes. And of course, you could simply sit down with them and say, look here, step 1, step 3, step 2, step 3, then they understood it, but still was quite hard for them if they were not aware how the system works. But at the end, what do we have now? Now we have really a list of concrete test executions to be executed in the system, and that can be handed over to our test machine system or test execution system, where I would like to emphasize, if you think about, okay, what is the main capability of my test execution system? You should be able to control the system. And you should be really able to control the system, because that's the most important thing, that you can control the system. Means that you should have the possibility to reset test agents, to make sure they are clean. You should be, also comes to your production code, you should be able to control your production code in the test execution to ensure that it cleans up stuff afterwards. Of course, you can do that also differently nowadays with containers or whatever. But in our case, we are still heavily on-prem, containers creeping in. And there, of course, it's very hard if someone spoils the test execution that it has impact on others. And that's why, where did we have that? Mentioned that. What we have there, for example, is that we really make sure that we have predefined scripts which should be used to set up parts of the system, so set up cleanup. And these prepare some things for the execution to make sure that the machines are not spoiled afterwards, because you always have to have there a trade-off decision. So for us, it's way faster that we reuse the same machines. Of course, you could simply say, use a VM snapshot, spin up a new VM, and set up the stuff there and throw the VM away. Takes more time. So we are not at that point that we really could use something like that. Of course, with containers in the future, we will also adapt there and have there easier solutions. But nowadays, we have to do it like that. And I mean, what's there also nice thing again is, as I mentioned, these are all isolated steps and rely on interfaces, and these really enable that you can change things in your system. And what we recently did is that we changed our test execution thing because we saw pictures like that. So that's here the number of machines which have been involved in this test execution for one specific build. And as you can see, the execution was quite scattered. Gray means machine not utilized. Green means, yeah, test running past there. I don't know if there's even a red somewhere. But as you can see, it's quite scattered. And that caused that builds took longer than needed. And of course, machines have been blocked for other builds for no reason. And that's what we changed now recently is that we are now have more such a picture that we work differently with a different system. So we started with Qt controller, Qt agent from Microsoft, if someone still knows that. So we've thrown that away. And now we work with a system where we can really better queue the stuff and execute in a more harmonized way our test runs. And therefore, of course, we reduce build time because you don't wait for machines to finish there. And if that is then done, at the end, of course, final thing, you get a test status report in some format imported to your build-in test into your CI/CD execution system, and get the report of the build, and then it's passed, failed, whatever. And yeah. Summary of what I said is, so I think what is very important, clearly separate your test execution into different steps and have defined interfaces between them. Don't make them depending on each other, because that gives you the flexibility later. So as mentioned, architecture and pipes and filters pattern. You should have collect always the data of the different steps to be able to optimize them. And you should define also clear constraints and boundaries and establish governance. So of course, freedom for the teams is very important. They should be able to react on their own. But in big systems, you have to give them guardrails and make sure they stay in these guardrails, because in such an execution, everyone has to stick to some rules to make sure that you can optimize too locally, because it's about the global execution time for all the teams. And and if you do it like that, I think you've seen that you can build up a system which scales over the time and can be evolved. Like I mentioned, now more and more containers creep in, edge deployments and cloud deployments, and there, of course, we can now adapt to the specific steps to fit the needs of the project to also bring in these technologies. That was it. If you want to reach me, my address, I think Siemens Healthineers will be still there for quite some time. I hope, at least. And thanks a lot.
Marco, thank you very much. Do you have any questions?
Hi, thanks a lot. I have a lot of questions. So I would be interested in the data that you've shown. Is that from pull requests, or do you run these pipelines only on main? And maybe let's start with that.
All. So we don't make a difference. So also in pull requests, we run builds with test execution. So nowadays, every try to commit something, I see a pull request also as a try to get merged, executes tests. And then, of course, it gets more important to have such a system, in my opinion, because based on that pull request, you want to give fast feedback. And so that's why it's based on all of them. But don't ask me now for the number of pull requests.
No, but then I would be interested in how many failures do you see? Because you're skipping tests, and then you could have situations where something gets onto main, and then you have the error on main and maybe blocking all other PRs.
Not so many. So simply that doesn't mean that we skip tests at all. So what happens, of course, that We then have later follow-up builds like nightly builds, where we pick up the rest of the tests to execute them and give the feedback. The thing is, we optimize the chain that a developer in ideal case gets the feedback after 15 to 20 minutes. The first feedback here, based on your impact, we executed these tests, everything is still green. And yes, there are still possibilities that one day later, the feedback comes, hey, in the nightly build, that specific test failed. But I would say, since we are also in trunk-based development for some time, the failure rate is not so high. So there's nothing I would be concerned about. But if you ask me now how many builds are failing, I typically have a look there when they leave this Pareto principle. So 20% failing, 80% passing. I think that's a typical rate in total, but simply means the people work on the code, if you ask me.
Okay, and then I'd be interested in what languages you work with. Like, what kind of software is it?
The main part is C#. Then we have still 20% C++, and what's currently coming in is Go. And they all work with similar approaches. The Go projects are fortunately very small, because by nature of Go there, and there we execute all tests which are there, but the rest uses that system.
All right. Thank you.